Hi, I'm Melinda Rose.
And I'm Laura Marshall, and this is Light Matters for October 5th, 2011. In this week's 5 Minutes to Enlightenment, a retrofitted iPhone becomes an inexpensive medical imaging device, giving light amnesia boosts solar cells, we present some notable business news, and a new scanner reveals secrets of ancient documents.
A team at UC Davis has MacGyvered an iPhone into a medical quality imaging and chemical detection device able to perform detailed microscopy and spectroscopy functions. The enhanced iPhones could help hospitals and clinics in developing countries with limited or no access to lab equipment, and can also transmit the data around the globe for further analysis and diagnosis. The team's microscope lens consists of a ball lens inserted into a hole in a rubber sheet that's taped over the phone's camera. The lens and camera together can resolve features on the order of 1.5 microns, small enough to ID different types of blood cells for anemia diagnosis. The light collected by the iPhone's camera sensor is also used in a simple spectrometer constructed from plastic tubing and electrical tape. Though still in its early stages, the researchers believe the spectrometer could measure oxygen amounts in the blood and help diagnose chemical markers of disease. The team will present their findings at Frontiers in Optics, OSA's 95th annual meeting in San Jose, California on October 19th.
For years, scientists have dealt with the problem of trying to increase the efficiency and drive down the cost of solar cells. Now they've hit upon a new idea, trying to give the collected light a bit of amnesia. Nanoscientists at Argonne National Laboratory are investigating the use of fluorescent plastics called luminescent solar concentrators for lowering electricity costs from solar cells. Concentrating sunlight is one strategy for squeezing more power out of existing solar cells, but the question has been, what's the best way to gather as much sunlight as cheaply as possible? Lenses and mirrors need an expensive tracking system to be continually re-aimed at the sun as it moves across the sky. Luminescent solar concentrators, or LSCs, are an inexpensive alternative that capture sunlight and change it to a different wavelength. LSCs act kind of like flat funnels, absorbing a lot of the light over the face of a plastic slab filled with dye, then redirecting it back out the edges, in theory intensifying the light. In practice, however, the light gets lost in the slabs due to reabsorption or scattering. The researchers took advantage of optical microcavity effects to produce a resonance shifting effect, in which light kind of gets amnesia, failing to recognize the environment from which it was emitted and drastically reducing reabsorption.
Samsung Ventures Investment Corp of Seoul, Korea, the venture capital arm of the Samsung Group, said it will become a shareholder in Germany-based organic LED maker Novaled. Novaled is known for its PIN OLED technology, which is especially suited for next-generation portable displays. Specific terms of the deal were not disclosed.
NeoPhotonics Corp., a maker of photonic integrated circuit-based modules and subsystems for high-speed communications networks, will acquire privately held Santur Corporation in a deal worth nearly $47 million. NeoPhotonics said combining Santur's active indium phosphide photonic integrated circuits with its hybrid PICs will provide customers with new products for 100G coherent systems and establish NeoPhotonics as a major vendor of client-side components for the cloud.
A multispectral scanner developed at Oxford University is being commercialized by a spin-out company, Oxford Multispectral Limited. The portable device uses flatbed scanner technology and image processing to scan visible and invisible features that absorb and reflect light at different wavelengths, such as inks, pigments, polymers, or papers. Developed for imaging ancient papyri, the new device has successfully scanned, restored, and archived more than 250,000 historically significant manuscripts. The system can take digital images at different wavelengths and layer them on top of each other. That allows it to see, for example, an artist's signature under multiple layers of paint or the pencil sketch under a watercolor. Oxford Multispectral is beginning to commercialize its product and will focus on restoring manuscripts and art, as well as on the huge potential market for forged documents and banknotes and forensic evidence.
Well, that's it for this edition of Light Matters. We hope you'll share the link to this video or any episode of Light Matters with a friend or colleague. You can do that simply by clicking on the icons at the bottom of this player.
We'd also love to hear from you. Please send your questions, comments, or suggestions to lightmatters@photonics.com. You can also follow Photonics Media on Facebook and Twitter.
Thanks for watching, and we hope you'll join us next week for another 5 Minutes to Enlightenment.
Well, light matters to me because it's a critical part of the economy of the United States of America. It's a big part of my university, which is home of CREOL, the College of Optics and Photonics. And we educate a lot of young people that go out and get jobs that make us all better. They make machines based on light for national defense, machines based on light for medicine, machines based on light for precision machining and manufacturing, and all aspects of the economy.
Oh, light is everything. Right now I'm actually in a solar class, and it's just so interesting. I don't even know what to tell you to explain it. But yeah, it's pretty much like everything right now. Is I believe it's the way that we can save the Earth.